So, good morning, students. How are you? Hope all of you are fine. So, today we will see how to construct an ellipse using general method or eccentricity method. So, what we are going to study? We are going to study about construction of ellipse, construction of ellipse using general method. What is the method which we are going to study? The method which we are going to study is general method. And this method is also called as eccentricity method. This method is also called as eccentricity method. Here, why we call this as eccentricity method? I will explain later. Okay. So, now, so if you want to construct an ellipse using general method, what data we require? What is the data we require to construct an ellipse using general method? So the first thing which we need is we need eccentricity of the ellipse. What we need? We need eccentricity of the ellipse. So in this problem, I am assuming that the eccentricity is 2 by 3. Okay, then the other data which we need is distance of focus. What is the other data? Distance of focus from directrix. Distance of focus from directrix. This is the other parameter which I need. So I am assuming that as 50 mm. Okay, dosto. So when the eccentricity and distance of focus from directrix are given to you, then what method you have to use? You have to use general method or eccentricity method. So if you want to use general method or eccentricity method, I need eccentricity of the ellipse and also distance of focus from directrix. So let the eccentricity be 2 by 3. Let the distance of focus from directrix be 50 mm. Using these two, how I am going to construct an ellipse? So it is very simple procedure. So very simple procedure. I am going to explain this using that a procedure. You can easily construct an ellipse here. Okay, dostom. Now, the first step which you have to do is draw a directrix which is a vertical line. Draw a directrix which is a vertical line. So I am assuming this as the directrix here. Okay. So I have drawn a directrix which is a vertical line here. Now this directrix I am taking that as AB. The directrix I am taking that as AB here. So what is this line which I have drawn here? The line which I have drawn here is called as directrix. The line which I have drawn here is called as directrix. What should be the length? You can draw of any length. You can take any length. Okay. Now, at any point on this directrix, I am taking that point as some point C. At any point on this directrix, draw a horizontal line. What I am drawing here? Draw a horizontal line. And this horizontal line is the axis of the ellipse which I am going to construct. So what is this horizontal line? This horizontal line is axis. What is the length of this line? Any length. So I have drawn two lines. One is the directrix, another one is the axis. Both are perpendicular to each other. So both are perpendicular to each other means both are at 90 degrees to each other. What is the length of these two lines? Any length. At what point you have to draw? You have to draw this axis at any point on the directrix. At any point on the directrix. Okay. Now I am going to locate focus here. I am going to locate focus here. So what is the distance of focus from the directrix? If you remember, in the data which is given to you, distance of focus from the directrix is given as 50 mm. Distance of focus from the directrix is given as 50 mm. So from C, at a distance of 50 mm, locate a point here which I am calling that as focus F here. So what is this distance CF? It is the distance of focus from the directrix, which is 50 mm as given in the problem. So in the problem, if it is given as 40 mm, mark F at a distance of 40 mm. If it is given as 60 mm, mark F at a distance of 60 mm from C. So because in this problem CF is given as 50 mm, I have marked the point F, which is focus at 50 mm from C here. Okay, dostom. Now, once we locate the focus F, now I am going to divide this CF into a number of parts. Into how many parts I have to divide? It depends upon the eccentricity. So what is the eccentricity which is given to you in the problem? The eccentricity is given as 2 by 3. Now, into how many parts I have to divide? Add numerator and denominator in the eccentricity. That means add 2 and 3. So what is the value, dostom, we got? We got 5. So add numerator and denominator. So what is the value? We got 5. Hence, divide this CF into 5 equal parts. Divide this CF into 5 equal parts here. So dostom, into how many parts we have to divide depends upon the eccentricity. So add numerator and denominator in the eccentricity. What is the value you are going to get? Into so many parts you have to divide here. So into how many parts I have to divide now? I have to divide now into 5 equal parts. I have to divide into 5 equal parts. Now you can see here, I have divided this into 5 equal parts. So first part, second part, third part, fourth part and fifth part. What is the length of each part? We have 50 mm as CF. So when CF is divided into 5 equal parts, each part length is 10 mm. So this is 10 mm, this part length is 10 mm, this part length is 10 mm, 10 mm and 10 mm. So total 5 tens 50 mm. So I have to divide this into 5 equal parts. Then the next step is you have to locate the vertex V. What I have to do? I have to locate the vertex V. So where I have to locate the vertex? Again, we have to go through the eccentricity. Now see the eccentricity. The numerator is 2. So count 2 parts from F. Count 2 parts from F. That means from this side. So this is the first part. This is the second part. Why I have taken only 2 parts? Because the numerator in the eccentricity is 2. Because the numerator in the eccentricity is 2, I have counted 2 parts from the focus. Now this part after second part, I am going to take that as vertex V here. So how you have to locate the vertex? Again, check the numerator in the eccentricity. Count so many parts from focus. After so many parts from focus, locate V, vertex. So here numerator is 2. So count 2 parts from the focus and locate vertex V here. Okay, that is the next step. Then once you locate the vertex, then draw a vertical line at vertex. Draw a vertical line at vertex. Okay, dostom, draw a vertical line at vertex. Then the next step is, I'm going to locate one point E on this vertical line. E on this vertical line. How I'm going to locate? VE should be equal to VF. What does that mean, dostom? Measure this VF, mark the same length here, then you are going to get point E here. Okay, so measure this VF. So in this case, VF is 20 mm. So mark the same length here, you will get the point E here. So this point is E. So VE should be VF. Satisfying this, locate E here. Okay, दोस्तों. Once you locate E, now join C and E. Join C and E and draw a straight line here. C and E and draw a straight line here. Okay, दोस्तों. So join C and E and draw a straight line using scale. Now once you draw this line, I'm going to locate a number of points on this axis. I'm going to locate a number of points on this axis. Where I have to locate? I can locate at any location. I can mark at any location. They need not be equal also. They need not be equal parts. Okay. So what I'm going to do here? I'm going to take one point somewhere here. Randomly, some other point somewhere here. Some other point somewhere here, some other point somewhere here. All these part lengths, they need not be equal. You can take randomly, you can locate randomly at any point. You can locate randomly here. You can locate randomly. So 5, 6, 7, 8, some number of points. Initially locate some points here. Okay, initially locate some points here. Okay, now once you locate all these points, okay, take the first point. Okay, दोस्तों, take the first point here. Draw a vertical line through this first point. So what I have to do? I have to draw a vertical line through this first point so that it intersects that red color line. So I have drawn a vertical line through this point 1. Okay. Then draw a vertical line through point 2. Draw a vertical line through point 2. Then draw a vertical line through point 3. Draw a vertical line through point 3. Draw a vertical line through point 4. Draw a vertical line through point 5. So दोस्तों, through each point here draw a number of vertical lines. Okay. Now the intersection of all these vertical lines, with this line, I am taking that as this point. I am taking that as 1 dash. This point I am taking that as 2 dash. This point I am taking that as 3 dash. This point I am taking that as 4 dash. This point I am taking that as 5 dash. Like that you will get 6 dash, 7 dash, 8 dash, 9 dash. Like that you will get a number of points here. You will get a number of points here. Okay. Now I am going to draw a number of arcs. I'm going to draw a number of arcs. How I'm going to draw? See here. So first, the center for all these arcs is F. What is the center, दोस्तों? F. Radius is, for the first arc, the radius is 1 1 dash. What is the radius, दोस्तों? 1 1 dash. What does that mean, दोस्तों? Take 1 1 dash as radius. Okay, दोस्तों. Take 1 1 dash as radius. F as center. I have told you to take F as center. Radius as 1 1 dash. So 1 1 dash as radius. Measure this length using compass. Then take F as center. Cut the same line which is 1 1 dash line. Cut the same line which is 1 1 dash line here. Okay, doston. So this intersection point I am taking that as some P1. What is that intersection point I am taking? So I will mark that intersection point with some red color so that you can easily locate. So this point I am taking that as P1 and this point I am taking that as P1 dash. I am taking that as P1 dash. here. Now observe here doston, what is the radius for to draw this arc? 1 1 dash. What is the center? F. So take 1 1 dash as radius, F as center, cut two arcs the same line, 1 1 dash. Okay doston. Now I will take the second one. What is the second line? 2 2 dash line. So the radius is 2 2 dash. The center is same doston, center will not change. The center will not change. So take F as center. So measure 2 2 dash using the compass. Measure 2 2 dash using the compass. F as center. Draw again two arcs. Draw again two arcs. Okay. Cut the same line. 2 2 dash line. Now you will get the intersection point. Take this point as P2. Take this intersection point as P2 dash. Now tell me what is the third line? The third line doston. The third one is 3 3 dash. So same center. Radius is 3 3 dash distance. So take 3 3 dash distance. Okay doston. Center is F. So with F as center, again draw an arc here. Again draw an arc here doston. So what are the points you are going to get now? You are going to get P3 here, and you are going to get P3 dash here. Now observe here. Yeah. You have two more lines, you have three more lines, four more lines. So for all these lines, again what you have to do, take F as center, 4 4 dash distance as radius. You will get two more points here. You will get P4 and you will get P4 dash here. Okay doston. Again take 5 5 dash, you will get P5 and you will get P5 dash here. Like that you will get a number of points here doston. You will get a number of points here. So once you got all these points, then what you have to do? Starting from V, draw a smooth arc joining all these points. Joining V, P1, P2, P3, P4, P5. On the other side, V, P1 dash, P2 dash, P3 dash, P4 dash, P5 dash. Starting from V, it should pass through V. Okay, so if we join all these points here, doston. Now see here, doston. So when I join all these points P1, P2, P3, P4, V, P1 dash, P2 dash, P3 dash, P4 dash, all those points, I got an elliptical curve. So the curve which I got here, this curve is called as ellipse or elliptical curve here. Okay doston. So this is how you can construct an elliptical curve here. Of course doston, I have drawn only 5 lines here, but you have to draw a line through 0.6, line through 0.7, line through 0.8. So when you locate all those points, when you draw all those, you will get a number of points here. Finally, using your pencil, you have to draw a smooth curve so that you will get an elliptical curve here. You will get an elliptical curve here. Okay doston. So this method is called as general method or eccentricity method, which is used to construct ellipse. Okay doston. Now what are the data parameters which we require? We require the distance of focus from the directrix. What does that mean? That means we need this distance here. In addition to that, we need the eccentricity. Okay doston. So dhanyawad. Thank you very much for listening to me on how to construct an ellipse using general method.